Okay, class, we're about to start section 3.4, and according to our syllabus, we're to do page 251, 1 through 18, and page 258, 1 through 12. Okay, lesson 3.4 is investing in yourself. The learning objectives: to understand different student loan options, to compute interest and monthly payments on a student loan, to evaluate the effects of capitalizing interest, to analyze various aspects of a mortgage, to compare two mortgages of different lengths, and to prepare an amortization schedule. Okay, so let's look down here at the bottom. It says student loans. There are three basic types of loans that most undergraduates might consider: federal loans made by the government, federal loans made by banks or other lenders but guaranteed by the government, and private loans. Every student's first choice should be the federal loans due to stability. The interest rates are fixed for the life of the loan and are regulated by Congress, so you're unlikely to end up with a nasty surprise somewhere down the line. There are, however, limits on the amount that can be borrowed for one student through federal loan programs, and private loans might be the only alternative for an especially expensive education. Other than the length of the loan, the big difference between student loans and other installment loans is that the payments are typically deferred until after graduation. This makes perfect sense, as in many cases students aren't working enough to make the money required to keep up with payments. So that's pretty good. So that's a pretty good deal. But it comes with a catch. In some cases, interest will accumulate on your loan while you're in school, even though you're not making any payments. This can increase the principal balance considerably. The loan term can vary depending on the amount borrowed, but the standard term is 10 years, with payments deferred until 6 months after graduation. Now we'll go here to page 352. It says interest on student loans is simple interest. The interest accrues only on the principal balance, not on previously accrued interest. So while the student is still in school, the amount of interest that accrues each month remains constant. The interest is calculated using the simplified daily interest formula, which we can develop using things we know about simple interest. If the principal balance of a loan is $6,500 and the interest rate is 6.8% annually, how much simple interest will accrue in 1 year? So we will use the interest formula: I equals principal times rate times time. So the interest is equal to the principal, which is 6,500, times the rate, which is 6.8%, which is 0.068, times the time, which is 1 year. So our interest would be $442. Now, it says number 2, why does it make sense to use 365.25 days in a year for financial calculations? It's the leap year. Every 4 years, there is an extra day added to the year. So 1 day divided by 4 is 0.25 days. So now we come here to question 3. It says using questions 1 and 2, find the daily amount of interest that accrues on that $6,500 loan. Make sure you explain how you got your answer. So it's $442 divided by the 365.25 days. So we could be totally accurate. So it'll be $1.21 per day. Now number 4, it says how much interest accrues in a month. Be careful. Now, it just depends. It depends on the month. There are 4 different calculations for months. We got 31 days in a month. So that would be $37.51 would be interest. We have 30 days in a month, which would be $1.21. That would give us $36.30 for that month. Then we have 29 days, which is the leap year, for February, which would be $35.09. And then we have the 28-day month, which would be $1.21, and that would be $33.88. So these are the calculations for each of the possible months. Okay, now at the bottom, it says the simplified daily interest formula. Daily interest amount is the principal balance times the interest rate divided by 365.25 days. The monthly interest amount is equal to daily interest amount times the days in a month. Okay, now we're moving on to the next page, to 253. And it says, for that $6,500 student loan we've been working with, if you start school in August, graduate in May, 3 years and 9 months later, and payments begin 6 months after graduation, how much time will pass when interest is accruing? Now that would be 4 years and 3 months. Because remember, you did 3 years, 9 months. You get a 6-month grace period. So we know we're 3 months shy of another year. So if we take 3 months off of here, that would make that another year. So that would be 4 years and 3 months will be left. Now, for number 6, it says write out the months that come after the last 4-year ends, then the number of days in each of those months. So we will have September, October, November. Those are the months that will come after. 30 days in September, 31 in October, and 30 in November. Number 7, it says find the amount of interest that accrues in the number of 4 years from your answer to question 5. So we know that it's $442, and we will multiply by 4 because it says by 4 years. So that would give us $1,768. Now number 8, it says write the amount of interest for each of the months listed in question 6. Your answer to question 4 will come in very handy. Okay. So number 8, we had September, which is 30 days. Now if we go back to problem, what was that? Question 4. Remember question 4, and I'll put this here. Question 4 told us that 30 days is $36.30. So September would be $36.30. Now October, which is 31 days, would be $37.51. And then finally November, which is another 30-day month, should be $36.30. Now, we go to question 9. It says how much total interest accrues before payments begin. So we have $1,768 plus the $36.30 plus the $37.51 plus the $36.30. So that would give us a grand total of $1,878.11. That would be our final amount. Okay, now we move on to the next page so we could go to problem 10. Now, on this page here, we start off, when interest is covered by the government while the borrower is still in school, a student loan is called subsidized. If interest is added to the principal while the borrower is in school, the loan is called unsubsidized. For the loan in questions 1 through 9, the student would have saved $1,878.11 by acquiring a subsidized loan. When monthly payments begin on a student loan, they're based on the principal balance at that point in time. These payments can be computed using the following formula, which should look familiar. It's exactly the payment formula we study in lesson 3.3. We just thought we'd be nice and recopy it rather than making you look on the previous pages. You should probably send us cash. Yeah, these corny jokes. Also, since most student loans have a 10-year term, we took the liberty of adapting the formula to that situation. Again, you should probably send us cash. Gift cards are appreciated. Yes. Okay, monthly payments on a student loan. For a 10-year student loan with principal P and interest rate R written as a decimal, the monthly payment M is given by this formula here. Now, if you notice here, the exponent is a negative 120 because that is the life of the loan, how many months you will have to end up paying. So that was the adjustment that they were talking about from the previous formula in 3.3. Reminder, perform the calculation in one step if you can. If not, don't round too much. Always use at least 4 decimal places, and more than that won't kill you. I promise. For the loan in questions 1 through 9, what is the principal amount at the time payments begin? Okay, the principal amount will be $6,500 plus the $1,878.11 in interest. So the principal amount will be $8,378.11. Now we're assuming that you got an unsubsidized loan. Okay, now 11. Find the monthly payment on the loan. So we have M is equal to, now as you all can see the formula up here. So we would be substituting the $8,378.11, substitute in for P, times the interest rate is 6.8%, so it would be 0.068 divided by 12, all over. We will have 1 minus 1 plus 0.068 divided by 12 to the negative 120 power. And that would be approximately $96.42. Now, I did show you all back in section 3.3 how to type this in the calculator, but I will take time out right now to show it one more time. Okay, so make sure you have your calculator on and ready to go. So now, what we would do, again, we would type in the numerator as is. So the numerator is $8,378.11 multiplied by, and we'll put in parentheses this fraction, 0.068 divided by 12, and we'll press enter. Now we get this long decimal here. We hit divided by, open parenthesis, 1 minus, parenthesis, 1 plus 0.068 divided by 12, close that parenthesis, and take it to the negative 120 power. Hit that right arrow one time to get it down to the regular size. Hit the close parenthesis, and as you see here, if we round it to decimal places, it's $96.42. Okay, now, it says here, we've seen that with the student loan, you have the option of not making any payments until after graduation. When interest on an unsubsidized student loan is not paid during college, we say that the interest is capitalized. When interest is capitalized, it adds to the principal balance, which of course results in larger payments. When interest is not capitalized, payments have to be made during college, but only covering the amount of interest. This keeps the principal balance the same until 4 monthly payments start, which makes those payments smaller. Okay, now, We go on to the next page. It says for the student loan we've been working with, the payment while still in school would simply be the amount of interest that's accruing, which you already calculated. For reference, in the space below, write the amount you pay in an average 30-day month. See question 4, as well as the total amount of interest you pay before regular monthly payments begin. Question 9. Okay, so it says for a 30-day month, according to what we did previously, it'll be $36.30. The total interest before payments is $1,878.11. Okay, number 12. With interest not capitalized, the principal balance of the loan will be $6,500 when full payments start. Find what those payments will be. So we have the same formula. The principal is $6,500 times the interest rate, which is 0.068, divided by 12, all over 1 minus 1 plus 0.068, divided by 12, to the negative 120 power. And that would give us approximately $74.80. Now, it said you'd make 120 payments on the loan since you have 10 years to pay it back. Use your answer from question 12 to find the total amount of money that you pay on the original $6,500 loan. Okay. So, we would take, well, they tell us a hint here. Don't forget the amount you would have already paid while in college. So, we would have the $74.80 times 120 payments, plus the amount of interest that we paid, which is $1,878.11. And that would give us a total of $10,854.11. Okay, now number 14. Now the key question when studying whether or not to capitalize the interest. If interest is capitalized, after paying nothing while in school, you'll end up making 120 payments of the amount you found in question 11. So, how much money would you save by paying the interest while still in school? More importantly, discuss with your group whether or not you think the amount saved would make it worthwhile to scrape together those payments while in school. Then write your thoughts. Okay, so we would have $96.42 times 120 payments, which would be $11,570.40. So we would take the $11,570.40 and subtract the $10,854.11, and that would have us a savings of $716.29. Okay, over the course of 10 years, that's really only $70 extra a year that you would save. By paying the interest while in school. It's a small price to pay to be able to wait and pay your interest when you're out of school and hopefully have a good job. Now, basically, what this is saying is that if you're like the typical college student that does not have that much money, paying that $1,878.78, $1,878.11, paying that while you're in college and you're a typical college student would be kind of tough. But if you have a good job, paying an extra $70 a year doesn't seem as bad. Now we go here to the next page. We have home buying. Now, instead of reading through all this with the home buying, we notice here that we have both mortgage, fixed rate mortgage, and adjustable rate mortgage. Well, let me just read through this. It says, for many people, the day they buy their home is one of the proudest days of their life and one of the scariest. There is nothing that compares to the feeling of looking at a house and knowing that it's all yours. But the buying process is tremendously intimidating. There are dozens of documents to sign, and the sheer numbers involved are enough to make almost everyone wonder if they're making a colossal mistake. The most common home loans are paid over a 30-year span. That's a major commitment, and one that nobody should enter into without an understanding of the mathematics that go into the process. In the remainder of this lesson, we will study that math, hopefully helping you to become a well-informed home buyer. Maybe you're thinking, dude, I'm a college student. Buying a house is like a million years away. If so, you would be surprised at how quickly that million year passes. I surely was. A mortgage is a long-term loan where the lender has the right to seize the property purchased if the payments are not made. Homes are the most common items bought using mortgages. The most common mortgage term is 30 years, but they are widely available in terms from 15 to as many as 50 years. Okay, there are several types of mortgages. With a fixed rate mortgage, the rate of interest remains the same for the entire term of the loan. The payments, usually monthly, stay the same. With an adjusted rate mortgage, the rate of interest may fluctuate, i.e., increase and decrease during the period of the loan. If you opt for an adjustable rate mortgage, it will start out with a lower interest rate than a fixed rate loan of the same length. Okay, so now it says discuss the pros and cons of fixed and adjustable rate mortgages. Okay, now with the fixed rate mortgage, so I say fixed, it's no uncertainty. This is a pro. But you are locked in this rate for the life of the loan. That's a pro and a con. The adjustable is great if the rates go down or if you pay off the mortgage before it adjusts, just higher. But it can go up in a very fast manner. 16. Discuss the pros and cons of buying a house compared to renting a place to live. Buying a house, you will have equity, but you have to pay for maintenance, repairs, and property taxes. Renting, someone else takes care of property tax, maintenance, and repairs. But you do not get the money back you pay in rent. Okay, so there's pros and cons on both sides. Okay, now for the next page, it says one of the most useful but frightening things about home buying is calculating how much money you will actually pay over the life of a loan. Let's see how that might work for one family. The Petty's family plans to buy a home for $224,900 and has been offered a 30-year mortgage with a rate of 5.5% if they make a 20% down payment. Calculate the down payment and the amount they'll have to borrow. So the home is $224,900. So they have to make a 20% down payment, which would give us $44,980. This is their down payment. Now, to find out the cost you need to borrow, or the amount you need to borrow, you subtract the $44,980 from the original cost of the home, which will leave $179,920 that you need to borrow. Number 18. I'm sorry, I went up off of the page here. Just to show this again, it's $224,900 at the 20% down payment, which would be $44,980. That'll be the down payment. And then we would take the $224,900 minus the down payment, which would give us $179,920 borrowed. Okay, number 18. The monthly payment of the loan will be $1,021,50. How much will the Pettys actually pay for their $224,900 home? Okay, and it says don't forget to add the down payment. So we have 30 times 12, which would be 360 payments. That's how many payments they make in a 30-year period. So we'll take $1,021.57 times 360 plus the $44,980 that was the down payment. So that would give a total of $412,745.20. That's how much they would pay for this house that originally cost $224,900, which is a big difference. Okay, now we'll turn to page 258 and look at problem number 1. In the space below, recopy the formula that we use for computing monthly payments on a student loan with a term of 10 years. Then describe the significance of each part of the formula requested below. So the monthly payment is P times R over 12 divided by 1 minus 1 plus R over 12 to the negative 120 power. Now we were talking about, now this is for a student loan, for a 10-year student loan. So if we were talking about a house, it'd be negative 360 and so on. So P is the principal on the loan, or you could say amount borrowed. R is the annual interest rate, which we know we have to write as a decimal. And 12 is the number of payments per year. Now number 2. It says, where do you think the 120 comes from in the formula? Hint, think of 120 as the product of two numbers. So it's the number of years times the number of payments per year. So remember, student loans are typically 10 years, so the number of years would be 10 times the number of payments. You pay 12 times a year, so that'll be 120. But the formula calls for it to be negative. Okay, now number 3. Using your answer to questions 1 and 2, adapt the student loan monthly payment formula into a general formula for finding the periodic payment on a loan with principal value P, annual interest rate R, term T in years, and end payments per year. Check with your professor to make sure that you have the right formula before moving on to the remainder of the lesson. This is the formula you should have. M is equal to P times R over N divided by 1 minus 1 plus R over N to the negative N times T. Okay, now we move on to problem number 4. It says earlier we studied a loan obtained by the Petty's family with these terms. Purchase price $224,900, 20% down payment, 30-year mortgage with a rate of 5.5%. The monthly payment was $1,021.57. So how much higher would the monthly payment be if they put only 10% down? This would also raise the interest rate to 5.8%. So we would take our $224,900 and multiply it by 10%, which would be a $22,490 down payment. So now the new principal would be $224,900 minus $22,490, which would give us $202,410. Okay, now we will put this in a formula. BM is equal to, now I'm going to rewrite the formula here because we do not have it on this page to show. So now we substitute. It'll be 202,410 times 0.058, because now it's 5.8% interest over 12 payments in that year. 1 minus 1 plus 0.058 divided by 12. Now we already know, since it's a mortgage and it's 30 years, it'd be to the negative 360 power, because that'd be the 12 times 30 we did before. So this would give us $1,187.65, which we would have to take our previous payment, which was, let's go back to page, let's see, it looks like we need to go back to page 2. It's actually not on another page, it's actually here in the directions, the monthly payment. So we would subtract this $1,021.57, and that would mean that you would pay $166.08 higher per month. Now it says how much more would they end up paying over the life of the loan. So we have $1,187.65 times 360 is equal to $450,044. So we would have $450,044 minus $412,745.20, which would equal to $37,298.80 more. Now remember, we had calculated this value actually on page 2. I believe it was on page 257. That's where we get the $412,745.20. It was problem number 18. So we compared the mortgage where they did a 20% down payment versus the mortgage where they did the 10% down payment and it had a higher interest rate. So this is the difference. Now for number 6, it says, now let's examine the term of the loan. If they choose a 15-year mortgage with 20% down payment at 5.5%, what would the monthly payment be? So we already wrote the monthly payment formula up here. So we're just going to substitute. We got M is equal to 179,920 times 0.055 all over 12. Now this 179,920, if you look back at page 17, it will show you how much that lowers the loan after a 20% down payment. Okay, now divided by 1 minus 1 plus 0.055 over 12. And then it's a 15-year mortgage. So we have negative 15 times 12. Now, 15 times 12 is really 180. So this would be a negative 180. So when we put this in our calculator, it'll be $1,470.10. That would be our monthly payment to pay it off 15 years earlier. Now number 7, how would their total cost compare to the other two options we studied? Which mortgage do you think is the best choice? So we would take $1,470.10 and multiply by 180, which would give us $309,598. Now that's how much the total is, but we also have to put in our, let's see, the down payment. So if we put that in, so we would add the $44,980 that we calculated back on problem number 18 on page 257. And when we add this, let's see, this would be 15. This would be $354,578. This is how much it would be for the 15-year. Now we would calculate the 30-year. So we would have that cost was $412,745 $745.20, which again is on page 257, problem 18. And we will subtract what we pay here, which is $354,578. And when we put that in our calculator, it would equal to $58,167.20. Okay, now we're going to do the 30-year mortgage where we only put 10% down. So that was $450,044, which we basically got that amount on page 258, I do believe. Actually, it wasn't page 258. It was actually this same page up here on problem number 5. We actually got the amount. Okay, so now we have the $450,044 minus the $354,578. And when we put that in our calculator, we would get, let's see, we would get a $95,466 savings. So basically, they asked us, which mortgage do you think is the best choice? The 15-year mortgage, if you can afford it, will save at least $58,167.20, and with the 20% down, you do not have to buy or pay PMI. Okay, now we move on to the next page. It says computing an amortization schedule. It says after securing a mortgage, the lending institution will prepare an amortization schedule. This schedule shows what part of the monthly payment is paid on the principal and what part of the monthly payment is paid in interest. Here's the procedure for computing an amortization schedule. Computing an amortization schedule. Find the interest for the first month. Use I equals PRT, where T equals 1/12. Enter the value in the column labeled interest. Step 2. Subtract the interest from the monthly payment to get the amount paid on the principal. Enter this amount in a column labeled payment on principal. Step 3. Subtract the amount of the payment on principal found in step 2 from the principal to get the balance of the loan. Enter this in a column labeled balance of loan. Repeat the steps using the amount of the balance found in step 3 for the new principal. Now, it says here, in the next group of questions, we'll use these steps to compute the first 3 months of an amortization table for the Petty's loan. The principal is $179,920 and the rate is 5.5%. The monthly payment is $1,021.57. A template for the table is included in question 12. Fill in the information as you find it. Okay, question 8. Calculate the interest for the first month on the loan and put it into the interest column of the table. So, the interest is equal to the principal, which is $179,920, multiplied by 0.055, which is the 5.5% interest, and that is divided by 12, which is $824.63. Now we go to number 9. It says subtract the interest from the monthly payment to get the amount paid on the principal. Then put that amount in the appropriate column in the table. So we will have the $1,021.57. That is the monthly payment, minus the $824.63, which is the interest, which would be equal to $196.94 will go to the principal. So now we will come back to add in 8 and 9 matter of fact, we can add that in now. The interest is $824.63. And this is this is actually the table above problem number 12. And the payment to the principal will be $196.94. And we got that from problem number 8 and 9. Now we go to number 10. It says, calculate the new balance of the loan by subtracting the payment on principal from the original principal, then put that in the last column. So we would take the $179,920 minus $196.94. And that would give us $179,723.06. So we will put the balance of the loan, which is $179,723.06. Now it says repeat the previous steps for the next 2 months. Do your calculations in this space, then put the results in the table. So for month 2, the interest is equal to the new principal, which is $179,723.06. Times 0.055 divided by 12 is equal to $823.73. Now we would take that monthly payment of $1,021.57 and subtract it from the interest, or subtract interest from it, which would be $823.73. And that would give us $197.84. So now we would take this $179,723.06 minus the $197.84, and that would give us a new principal of $179,525.22. So now we will fill in these boxes here. It'd be the $823.73, the $197.84 that will go to the principal, and then the new balance is $179,525.22. As you see, the interest is going down, the payment to the principal is going up, and the balance is going down. Okay, now we need to do month 3. The interest is equal to the new principal, which is $179,525.22. And we will multiply that by 0.055 divided by 12, and that would give us $822.82. So we would take that monthly payment of $1,021.57 and subtract the $822.82 from it, and that would give us $198.75. Now to get our new principal, we will have our $179,525.22 minus the $198.75, and that would give us a total of $179,326.47. Now we need to fill in the rest of the table. Our first value, the new interest of the payment would be $822.82 because the payment would still stay $1,021.57. But now this would be how much is going to the interest. What's going to the principal is $198.75. And then that would lower our balance on our loan to $179,326.47. Now for number 12, it says, what does this table say about what the bulk of your payment goes to when you begin making payments on a loan? Early on, most of the payment goes to interest. Now it says, what about near the end of the term of your loan? Near the end, most of the payment would go to the principal. And that is it.